Good morning, good afternoon, good evening. So today we will be looking at at our break command again, making sure that A, we understand what it's doing, and B, understanding why it's not doing what it's doing. And if you've watched it before, you will have noticed that it does not conform to the it works in a way, and conforming is probably not the right word. It doesn't work as expected. I expected it to set the program counter to 2 bytes after where it's called, which is the next instruction. So when you do return from the break or from the interrupt, it will, if you want, the program can just work as normal. The BBC Micro and others use the break command as essentially what the PC BIOS does, which is an interrupt. You set an address in memory to a number. You do your break command. The break command interprets that address in memory and does something else, and then returns 2 bytes after your break command. We're not seeing that. What we see is if, for example, after the break command in here, it has the address there in the stack. So whether it's something I'm doing wrong in pulling data off the stack, it could be. It may also be that it shouldn't be, because these three here are what is suggested in some literature. You pull the flags, pull your address low, you pull your address high, and then you do whatever else you need to. At this point, all I'm doing is disabling the interrupts. I don't want another interrupt to happen while I'm doing this interrupt. I'm storing the A register, storing the X register, and storing the Y register, not on the stack though, in different locations. And then I'm getting those the stack, the flags, the address low, address high off the stack. There's no need to have a look at this other bit here, but we do have your JSR to echo, which honestly doesn't work. I'm also getting the stack pointer as well, where the current stack pointer is. So, but this bit here does not work at all for me when I do the break command. So there's something I'm not doing right there, or I don't know. Echo may not work at that point. And then once we've done that, we've got a jump to reset, which works. The other one is an RTS, return from is it RTS? I better check. There's a return from interrupt as well. I think it's RTI we could also do, which, if we have not destroyed the stack, where's RTI? Yeah, return from interrupt, which we're not using at all. We're just resetting the stack and there's up here in the reset, past the code we're going to be running also. Okay, now I'm lost in my own code. But the reset literally just all the reset does is just resets the stack to the top and goes to the soft reset for the monitor. Alright, so the other thing I'm concerned about is that the 6502 processor that I've bought online is not an authentic 6502 processor because of what's happening with the break instruction. Let's go to the browser. Okay, so at 6502.org you have a lot of documents. Alright, I'll bring you guys to the browser now. Alright, so in the browser, in the 6502.org, we've got a lot of data here, and the one I really want to find is documents for okay, that's not what I wanted. It's for the processor, and it is an errata document for the processor. Actually, what we could do is 6502. Bugs and quirks. Okay, so the rotate right. Okay, so undocumented instructions, and indirect jump is partially broken. Okay, so NMOS line, we've got an issue there, but we've got a CMOS chip. It's a Rockwell derivative, date code 46 week 1992. So it is quite an old chip. And I've also got another Rockwell one there, which is dated 1986, 34th week, made in Mexico. It's a dash 13. The other one is also a dash 13 that I've already got on the processor. That one's a dash 13 1991, which didn't work in the processor in the computer, and that's a dash 13 which also didn't work in the computer, which is the 1986 1991 and 1986 34th week. We will swap that over and check as well, but let's carry on with the errata. So we're looking at this one here, index addressing, cross page boundaries. So essentially we may need to change where we're initially jumping to as well. Okay, we're staying in binary, so we're not worried about the this one here. Okay, that's an interesting one. I'm pretty sure I've got CMOS. Okay, this is this one here. I got a big smile on my face reading some of this. So the BRK Instruction. Okay, cool. That's not going to affect us because we do not have... We've got to pull up on that interrupt pin. I believe I've got to pull up on that interrupt pin. I have got to pull up on that interrupt pin. Okay, jump to service routine and return. Okay, so when executing the JSR routine and RTS instructions, the return address is pushed to the stack by JSR is that of the last byte of the JSR operand. Most okay, that's an interesting one. So I've been using JSR and RTS. That might be an interesting one to look at. Right. Let's see. Citations. Pretty sure I've got this applications book. Oh no, I haven't got that one. Okay. Rodney's X again. User manual. Okay, open the tab and cool. Not worried about that one. I'm pretty sure I've got that book. Instant reference card. Let's have a look at that one there. This is where I can get distracted, which is not a good thing. And FPGAs as well. Okay, so we shall. Okay, so we'll ignore those for the moment and bring up Putty and bring you guys to Putty as well. So at this stage, I'm going to struggle putting an IC into a socket and see how I go. Be nice, be nice. There we go. It's like pulling teeth. Alright, so a random 6502 processor I found. Will it work? Power's off. And of course the pins are not all in the right place. Yeah, it was easier. Alright. So one of two things is going to happen for this processor. First one is that it will just print a C, which is weird. But after reading what I've read, it could be a function of some of the JSRs and stuff, or where it's where the memory is located. Let's see here. Let's press the reset button. Let's press the button. Whoa, that 6502 works. Awesome. I got two that works on that board. So stoked. So stoked. Alright. Now I'll bring the code up. Where's the browser and editor? There's my editor. No, Hexhead. I want that one. And we go past the mem test, run basic. Let's see if this break command actually works on this processor. The only other thing I can think of is that the 6502 I've got is not a 6502, it's something else. Or was using. That's my biggest concern. Is that it wasn't the right processor, or it was... the top had been skimmed and laser etched, but it's not laser etched, it's silk screened. Alright, what I'm doing now is just compiling and... oh crap, 777. Six seven 6777. Ah, RTS. There we go. It's not going to reach that piece of code because it'll hit the jump first and there's no way to get to it. Let's load it. Oops. And my computer is running slow. I might need to replace the laptop with something a little bit more faster. Program. And what are we doing here? Alright, I've programmed it. Back to putty, switch it on. That's awesome. Okay, so we're just going to clear 50. That feels a lot faster. Something's not right. And then we do the command to run that, and let's see where that is. Where is that? Got OSI list, what we don't need. Monitor list is that one there. And E4B6. Loading basic and things, and it's done RTS. No, it hasn't done RTS, it's just done its thing. Done the break and run. That really does feel a lot quicker. Alright, so the HMMC is actually a date code. Don't worry about that bit on the top. I just remembered to put that in. That's it's an IEEE format, so it's just interpreting the characters as the data as characters, and it's just going to show that I have uploaded the correct ROM to the EEPROM, or binary file to the EEPROM. So let's inspect address 50 and E4CE. E4CE is where the break... ah, effing awesome. That works. Yes. 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 Okay. Now that's okay. Right. Why is that other one doing something completely different to this one? Oh, jeez. Oh, that's not fair. That is not fair. Um, mm, I don't want to decap it, but this it's either a 6502 that's working or a 6502 that's faulty. That's the original one I was using. That's not nice. Where did I put it? Yeah, because it's got nothing on the back of it. It's silk screened. It does not look like it's been laser etched. There's nothing on the back of it like the other 6502 does. So what's the difference between a 6502? No, there's still 6502 AP. What are you? Alright, let's not worry about that because I have now got to figure out where I put the other brake. Because we did change something and not the defines. Sorry, I've been distracted. Alright, I'm back. I just heard gas leaking and it's just the SpaceX conducting an engine test for the super heavy booster. And so I'm just waiting for that to do what its thing it is. I think it's supposed to be doing. I don't know if I've missed it. No, I wouldn't have missed it. They would stop streaming. Right. Let's go and find out. As I'm pretty sure I did something to one of the files and put a break in. Let's find out where I was making a mess of the OSI. And it is in, actually, okay, so it's okay, so it is still crashing, but yep. Yep. Right. Power cycle it. So it's telling me there's 492 bytes free. I'm going to try something here. Alright, let's not try that. I was going to remove the one of the RAM and see if it worked from there, but it didn't want to come out, so I'm not going to force it. Yeah, so 409 bytes, OSI 6502 basic. This is the thing here. If I do 50.60, that should show the address that it was trying to read from. 34C, 342C, and if we do 34 dot, nope, 342C to, come on, press the right buttons, man. 342C dot 3430. And that's where it's fallen over. Alright, let's go back and the OSI config, we don't need to touch that. It's the defines, and we set it to start there. Let's try 300. Oh, too many zeros. Those are good. And back into our code, my code, to monitor. We go up to start basic, and we remove that. Check RAM. And print line we're not worried about. Get character. Character out. Those ones there work, so let's turn that off. This time we are programming the EEPROM. I like how it actually told me how many bytes are free. 409. 4095. Load. Where are we going here? Nope. I don't want to burn the monitor. Yes. Still 8K. That said it was 8K. Let's check to see, make sure it's the right size. Nope. Told me the size of the folder. Clicked on the wrong one. It is 7.72 kilobytes of data. Okay. program it. I really could put it at 200 because then it doesn't really matter. Yeah, let's put it. No, let's just run it from there. Okay, so back to putty. Flick it on. Reset it. Okay, and then I've got to find the address we load for run basic, and okay, so that one there, that FF run basic is where? FF37. So there's a couple of ways to get to it anyway. So if we use FF17, FF37 will get us to jump to loading basic and things. And what the F happened there? Oh, because I didn't do this one here. Cool. Right, I forgot to where is it? CD dot dot. Turn that off. And load that. Cool. I made two changes, and one was to the basic where it starts off. The second change was to the monitor, and we failed to program the EEPROM. Okay, and flick that out. Do it the right way. Oh, give me a prompt. Didn't give you guys the prompt, and we'll reload it. And okay, so let's go over what's going to happen. We are going to call the memory address FF37, which is then going to give us run basic. And then from there we can see if basic works. We've removed our break, and we're also going to clear our carry. Sets SED set to can't remember what SED means. SED is set something, set decimal mode. Whether it needs that, I don't think it does. I can get rid of decimal mode and see if it works from there, but we didn't start it. Okay, so QMC, extra space. As you can see, it was HMMC, and FF37 and R. Memory size, yes. Alright. If we press enter, it crashes. So this is where I think we have to change, get rid of the SCD, and we do that now. Yes, we will get to memtest. We'll get to it soon. And a small win by finding a 6502 processor on the floor and saying, ooh, I could use that one. Gets nice and warm though. Mind you, the BBC Micro one gets quite warm too. The other one was practically cold. One of the things is the 6502 and the 68 something have a very similar pinout. The Apple one used the 68, was going to use a 6800 series, but I don't think they did in the end because of cost, or whatever other reason, or it could be the fact that there's a lot of 6502 code out there with the KIM, the BBC, the OSI Challenger, which is the basic we're using, and yeah, let's give it a go. Nope, that's not what I wanted. Turn that off, turn that on, move that. Okay. Okay, so we're still crashed there. Oh, 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 oh. Okay, so it crashes at A0. No, that can't be right. Why does it crash there? So every time it reads 00, it thinks it's a break. And it's 2 bytes before that. So whatever is it 2 bytes before that. Unless it is trying to load further down in memory. Well, it's not trying to load. It's trying to... From my understanding, when you press the enter key without entering in the memory size, it looks for memory. So it could be failing on that because one of the memories is giving back bad memory. That's why I've got the memory test there. Oh, that's come back before. Yep. Okay, let's do a reset. Now the thing with the reset is that it's still got the garbage, whether it's got that garbage. Alright. Loading basic and things. Let's see here. 4096. And it doesn't like that at all. So we can get away with 8902. Eight 119. Oh crap. Eight 8192 is the memory size. Okay. What the F? Like it works and then it doesn't want to work. So okay, so directly from DD15, we've got memory size is 8192. Okay, it's changed it, put the SED back in there. But I'm pretty sure I did DD1215 before and it ran quite nicely. Alright, so distracted again, watching the SpaceX booster thing. And Did I compile it? Did now. Right, let's try DD15, reset it. See, it gets to that point there, and then it, wait, 7423. Because we did move it down to 300. If we move it to elsewhere, but why does it fail there? It's hard to say where it's failing. 3723, which is probably 3721. Son of a... Okay, so we have memory test. And to run memory test, we have a look at our monitor listing. Yes, we go find where the memory test is, and it is actually, let's go read the document for memory test and see how it works. I've forgotten how it works. Where are we hiding here? PDF, PuTTY, browser. Get rid of PuTTY. Oh, right on that page. And here it is. So okay, this is it. To run, set the address of the first and last memory pages you wish to test in location 0 and 01. So to test pages 1 and 2 in Kim, we set to, okay, to 1 to 2. And so a page is 256 bytes. As the counter can only do 256 bytes, or FF. So if we want to test the entire range, we need to know how many pages we've got. And for that, we do a... find our calculator first. Alright, so... decimal. 1024 times 64 equals 65536 divided by 56 equals 256 pages. Yeah, so 256 pages. So 256. So we cannot test the first 2 pages. The first, or can we? Let's see here. So the first page is 0 to 100. And that's the 0 page. So that's the second page is 100. It's actually to 0 FF. Second page is from 100 to 1F, F, and that's the stack. The third page is from 20022 F, and we're not using that at all, so we can go from the third page, and if we want to test 8192 or 808K of RAM divided by 256 equals 32 pages. So 32. So we're testing from 3 to 32. So in memory location, I'm going to bring that. Where are we heading? Putty and editor. So in memory location, we're going to add 60. We're going to add 0, 3 and 32 in the end page. Alright, and then we do a E4D, E4D 3, and we're going to run from there. And where does that output that data to? And whatever it's just done, it's just failed. Alright. Now we're going to figure out what failed and how it failed. Unless it's still working. And I cannot tell because it's... Man, that gets warm. Let's see here. Okay, so... Okay, so 0 to 100. So hopes. Okay, how do I see where that is? Now that will be... So it should go back to my reset for me. And I guess if we look at... Let's reset it. And we go 60 dot... How many pages? Or how many places? 60.66. We can see that we got through to the third, pointer low, pointer high, mod, flag, flip. So they've been set. So the only other thing I can think of is that I have sets. Ah, crap. No, it's alright. I thought about something and it wasn't right. I don't think we're going to see anything in here for... Let's just reset this here. Okay, so 60 gets the third one, and next one gets 32. So 32 pages. Okay, cool. And then we run that again. Let's try this again. D3. And it will probably stop a A9, and okay, so if it fails, it should just break to here. I'd hate to think I'm dealing with dodgy RAM now. Okay, so point low, point high. Let's clear all the RAM that we're going to be using. So that's cleared. 60, and then we enter in what we want to read from and to. Check it. E4D3. Run it. Watch it crash. I don't know if it is crashing or what. Then we do 60.6F, and we can see that it has loaded. So those two, what we load. Point low hasn't been loaded, point high has been. Flags have not been touched, mod and flip. So flags have been touched. So load X to store X into mod. So store X is not 2, so we know it's gone past here. Load accumulator memtest start, so which is 03, and then point high, store a accumulator point high. So point high is that one there. That's point low, so we know it's getting to there. And load accumulator flag. So flag is set to that's flag E or A, and then store accumulator with flip. So that's that bit there. Alright. So point low. So it starts off at point low. Y is going to be transfer A into Y. Y is going to be 0. So this is going to start off at point low, which is this one. Yep. This bit here. Increment Y is Y clear. Okay, so we can check at 300. Okay, cool. So it's actually cleared that there. So it's written that data to that point there. Enter to 4FF. Okay. Cool. So okay, so 4,000. It's not writing anything. It's just getting dodgy data. All right, so where is the top of our memory address then? Okay, 2,000 is the top. Oh, yeah, 2 to 4K. So 0 to 2,000 hex is the first one. Well, RAM 0, and 2,000 to 4,000 is RAM 1. Okay, cool. Okay, so it's set up. Now it tests it, and okay, so it's got to that. It's got to the end. All right, I'm just going to bring you up to the PDF, and let's go through that. I may have made a mistake somewhere. Well, more than likely made a mistake. And it's not a copy and paste one either. PDF, 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 PDF. There we go. Alright, and we'll move. Right. Okay, so the names I have do not match up to a certain degree. We have your begin and begin and end, which I've just got mem start and mem end. We know it is getting to the point where it's writing or clearing the points. If we were to put that to if in that location 60 something or other, flipping it would mean that would be zeros in that location, and we're only doing 3 to 32, so it shouldn't go any further than that page. It's only doing the first memory then. No, it's doing the second one as well. Yeah, it should be 32 pages. Okay, what we're going to do is actually just check to see if this code matches what I've written down. Okay, so this is all in 0 page, and we know this works at this location. So mem test start is the begin and the end. Point L, point H, flag, mod, and flip. And mem test is start. So at the start, we're loading the accumulator, transferring A into Y, so we're zero the Y. Okay, so just turning the processor off, the computer off. That 6502 gets warm, very warm. And for low. And store point AL, store the flag. Ah, so it's gone through the second pass. If that has been set to 0, then that's the first pass, and then the second pass it sets to. And then mod was. I got that on the page. What is the sixth one? Start, end, pointer low, pointer high, flag, mod, flip. So mod was 0, 2. Low and high. So it's telling me it's getting to the third and failing there. That doesn't make sense. Okay, so big LP. That label's not been used. I haven't seen it, unless I've missed it. Okay, load X mod, load a beginning, pointer high, store it, load X the end, load accumulator the flag, flip it around, store accumulator flip, clear STA, clear store accumulator and point L, comma Y, which is whatever page that is, and let's see, whatever page that is, and the Y offset, increment Y, so incrementing the offset, Y is not 0, which means it hasn't got to roll over. Clear it, jump back there, so that's just looping over until Y becomes 0 again. So at FF, it will go to 0, and then it just falls through here, increment point H, clear, compare X to H, so X has been loaded with 2. And as you can see, there's no comments there. BC is clear, and so you're comparing memory address to X, and then BCS is break on carry. No, break clear. Branch carry set. So if carry was set, load X mod, load accumulator at the beginning, store accumulator, point H, fill LDL flag, and change values. So this is changing what we're storing. So this is from 0, 0, we'll go into FF. We've seen FF in each of those locations, so let's see where we go here. Top decrement X, BPL break. Oh man, so many breaks. BPL. Branch of pass result. Add one if branch accumulates. Same page, it's right. That could be where it is because we're in a different page. This has been loaded low down in memory. I've got it in high up in memory. That could be an issue. Let's see where we skip increment y, increments bracket not equal to top, increment pointer h, load the end, compare pointer h as the end, BCS fill. Alright, so X BPR slip, LDX to LDO flag, slip. 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 Okay, so I think we found the mistake. Compare point compare point L Y offset. So that is doing a comparison with memory, and there is a missing increment Y. Pop mod BPL flags, audio flags, EOR, BMI, big slip, STI, still Y point L. Okay, so point Y is L. So, okay, store Y. So store Y is L. So that there. So point low. And what I'm going to do is change that to result. Okay, result equals test plus, and it's 1 in size, 0.7. Cool. That should work now. Nope, it won't because we have not set the result down the bottom here. So instead of pointing it to there, we just go result. Okay. Now we can build it. Oop. Now we can build it. It's built. Unload it. Right. And it's been 1:10. So after this mem test is done, I'm pretty sure it's going to pass. It will tell us the size. I'm going to have a break. I might be back later on today. I might not be. We don't know yet. See how I feel. That's the load. Cool, that's loaded, and okay, so you guys get to see the code. I'll bring up Putty. Oh, where are you hiding, mouse? Okay, so Putty, and scroll all the way down to the bottom. That runs, and so 60, we're going to load it with 0, 3, 32. 60.6f, we can run it. Okay, so I'm going to bring up my there. Okay, I just need this bit here. So the 7th one is going to be 67. No, 67. That's the result. So that's where everything's going to not turn to custard. And I need to know where our address is we're launching it from, which is E4D3. E4D3. Run it. Hey, success. Was that increment Y? Oh no, 44D3. That's not right. Oh no, it crashed again. Okay, so we've still got an issue with it. I do not know where it's crashing. Though, so now breakpoint is now working. We can debug it in a sense, and I've got move here, haven't I? So if I can move that to here, it's not going to work for me though. Okay. So FF move, is that going to work for us? That's not. What we'll do is okay, so mem test, we know it's not getting to a certain point. So what we'll do is we'll do, nope, this is not the one I wanted. So we're sure it's getting down to here. And if we do BRK, actually, how do we do a macro? Because if I do, I might do is new file, control save, nope. Okay, so we can then do okay. Let's bring up the browser, get rid of those two there, and let's see, how do we do a macro in C in the assembler? Don't want control commands. So contents. Macpack, macro. There we go. See macros. Okay, so that's the macro, but how do we... Oh, okay, so ASR, macro name, whatever it is, and then comments, and then we can do back into our editor. I'll bring it to the editor. Cool. And so syntax is .m we're going to call this BRK BRK, and then we do a tab and we do a BRK and NOP, and then we do a end as end macro, and it's okay. We can do lowercase macro or just question is, where did that name come from? Okay, so we can compile that. Cool, it has compiled, and then we can just add the macro to where we want to have a break, and okay, so it's not getting too down to here, or it's getting down to here and it is in an endless loop and it's not breaking out of the loop. First of all, we'll try here for the break and see what we get. Cool, that worked. Turn it off, move the ROM. Nope, we'll do that. Alright, let's turn it on and let's find out where that macro is. Or did I did. Nope, I can do this here first. No, it's not. It's not that. I haven't put that in yet. Modified, and the address it loads at. Alright, so the address it loads at is that point where you start losing your voice because you said you're going to stop 10 minutes ago and it's now 20 minutes later. Almost 20 minutes later. It's 10 minutes later. Cool. I just, for some reason, saw something else that I didn't think was there. That's right, I watched FF. E4D3. And we run it. Okay, so it didn't work there. It failed further up. C8FF. And we're nowhere near C8FF, so that's alright. And what we can do is... Ha, see? There's my break. 00 EA. let's find out where it's falling over. Now, there was one of these commands where it was instructions where I think it was BPL, where it was depending on where it is, it'll fail. Or it's on a, what is it, BPL? Where it can be either a 0 page or other. I could be wrong. Yeah, okay, branch pass result. And it's going to be branch relative. So it's either going to be, let's bring it up to here. So this is the same as a jump, and you can only jump a certain amount of spaces north or south of the instruction. So BPL slip, so 0, 6, that's 6 places positive, so that's to there. And then to do negative, if it was negative 6, we clear that. Go to hex and 6, and we do a invert that. That's not going to work on this. Where's it? Invert not, and then we take away 1 equals that, and it'll be F8 places, which doesn't make sense, does it? That's right, not worry about it. There's fill EC, so that's negative, which is, no, that's positive. No, that's negative, so that one there's a negative number. It's EC, and CF, EC, and we not that, and that goes to 13. So EC is 13, and it's 13 memory locations. Let's see here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 13 is negative 27, and we remove all those. It's not, it's negative 18. $255. Okay, I need to brush up on that. Oh, get rid of calculator. Right. Okay, so after getting sidetracked, let's remove break from there, which we have. Okay, and see if it gets to there. The other thing I could do is just, ooh, I could do that. No, that's not working either. I was thinking is re-enabling the Intel code and or Intel download code and using that to do it, but I don't want to check to see if it's failed or working today, because it's I just want to concentrate on one thing, not get sidetracked again. Okay, so the chip has been burnt or programmed. And let's turn it on and see how we go. And you know what I've forgotten? There we go. E4D3. Okay. Test start, test end. Alright, so test start. Alright. So 60, we're adding 03, 32, start and end, or how many bytes, how many pages, and then at E4D3 we run it, and okay, cool. That's what we want to see, where it's getting to just before it breaks. So we know it gets to that point before it breaks. Yep, wrong screen. And onto here. Okay, so we know it's getting to the break not equal to clear, so it's actually getting to this point here. We did have it down here. Actually, if I put that there, and if we go through to the listing, we can see that the next address is going to be E4F1 and 50.50F. E4F1 is going to be the next address that it runs from, which means everything at this location here is correct to the certain point, except our Y, X, Y, yeah, those pointers should be fine. And yeah, this might be better if we do the Intel one, because that way I can add, while it's in memory, a break and take out that break, as long as that break is a triple or a double, all depending on which code, because you'd put a break here and it would point to this one here, but they're all doubles except for that one there. Okay, so where shall we put the next break? Just a certain value to place the break. Okay. Okay, I'll go to 12 o'clock. It's lunchtime for me. Okay, so it gets to that point, and so we're seeing that it gets to the store A, and then we're going to load down through to here. And again, we're just going to add works to here. Okay, so trying to figure out where it breaks, and instead of adding one and doing the test, I'm just going to add them in places where I feel it's not working. Okay, so that's just going to add a whole pile of breaks into the mix. And that's just going to help us narrow it down instead of just relying on one, because we can easily use that jump address to say, yep, it's worked, let's go to the next one. Program. You may ask, why am I spending so much time doing these breaks when I could just be trying to debug why BASIC's not running? This is part of debugging why BASIC's not running. It is testing to see if the RAM's okay, because it is failing at a point, and I do not know if it is failing because of the RAM or some other reason. So third page, 32 pages to count, end page, and we go to E4D3, it stops there, 50.5F. Next page is going to be C8FF. Okay, so the next one is going to be, it's not what I wanted. Let's bring up the, you guys can see it, I cannot. That one, where's the list? There it is. Okay, so that's the first one. It says E8FF. I got C8FF. This is not going to run all the way through though anyway, so E506. So E506, so it gets to the next instruction is that one there. So we know it works to that point there. Okay, and okay, so it must call top. Right, so we've called top again. Right. So that's why it's come back to there, because Y has a different value now. And that should be visible in our debug here. So from memory, this is the address. I'm pretty sure I did X, Y, A. Stack pointer is that one there. But E506R, this is going to do this for quite a while, so that might have been an interesting place to put it, but if we've got to go through Y 256 times, that's going to be tedious. D2 FC, so it's stuck on that location. It's probably going to be stuck on that location because of the code. I'm going to remove that breakpoint there because I know it's getting to there and it's going backwards and forwards between that bit, and it's probably a bad idea to put it there. Let's see here. So that one there. Okay, so it works here. Question mark, because we know that it's doing a loop through that bit. Now we want to see if it gets through that loop to this next break, and at which point there may be, I don't know if there's going to be a jump back up to fill or not. Okay, so let's save it, compile it. Let's not compile it, let's assemble it. Program. And let's run it, and I'll bring up my code. Where are we? List that one there. Bring up Putty, and I'm gonna try and run it without the EEPROM in there. So it doesn't matter what size we put at the moment because it's debugging, and I've got all those breakpoints in there. So we have, in a sense, a almost proper debugger. Almost. I can set breakpoints, but I cannot set them in EEPROM. And I cannot single step or step over or step through, so it's a bit, yeah. I wonder if I could change the microphone place. Currently it's to my left and it is almost in the way. I want to move it further down, but again it's going to be in the way. Right. E4 D3 run, and now we're getting somewhere. So at some point between here and here we have a failure. So what is that failure? I don't know. We can narrow down and see what it is. But what we can do is just reset it, and 50 is not going to show anything. But C8 FF is not a location we're using. And examining the stack, doesn't really give us much in the way of what's going on, as well as there are no JSRs or anything like that. It's all increment Y, break not equal, load accumulator, test in, compare to pointer H, the height stop, and break BCS fill. Okay, and fill is back up here. So I could get through to here. It could still be failing up here as well. So we can set to say that is where it could be failing, through here somewhere. And I've taken it as verbatim that that code is correct as well. There could be an issue with it. Let's have a look. Seeing it as a PDF that has been dragged in off the internet. And fill, load accumulator flag. Load accumulator. Fill, load accumulator flag. Decrement X. BPR skip. Load XY. Oh, right. 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 Oh, I see what the issue is. I read load X2 and I've written down load Y2. Okay. Load X2. Where are we? Top. Load X, load Y. So LDX. Right. And I'm quite confident this is going to work, so I'm going to remove these breaks. I'm not in the mood. I got a minute. And remove that one. Okay, so we should see in reset the results. And this is cutting it fine. Load. Monitor bin. And oh, gotta take the chip out, turn the processor off first. I'm just looking at how long I've been streaming for, and it's an hour 44. I'm thinking, well, I could take it to 2 hours, but the problem is then usually I take it to 3 hours or 4 hours and 5 hours. Cool. Right, 60. We are going to go from page 03 to page 32. We can check that there is 32, page 3 to page 32. We can then go E4D3 and run it. And, you mother crying out loud. Oh, it just took forever. Right, and 60.6F. And it got to page, where the hell is result? Result is the 7th. Or we'll just go 67. 00. That's not what we wanted. Store Y result, jump, FF reset. So, okay, I'm going to bring you up to the PDF. Let's get rid of putty, and let's read through this again. So, no, we don't want that. To run. So we've set the first and last memory page you wish to test. So, and that's in 00 to 01. We've got a slightly different. Start the program at address 02. It will halt with a memory address on this display. If a fault is found, its address will be displayed. Okay, so it's one part passed, and okay, that's why. So that's the counter. I'm missing a bit then. So it's result high, result low, and that is going to be L. And so result high Okay, so result low, it's going to be stored at location 08. Result high is location 7. And I didn't show you guys what I just did. Straight back to the PDF. Okay, so pointer low. And we're jumping to out. So pointer high will be the end location, the end address. So where are we hiding here? Let's bring you back to the editor. Let's see what I've done. So I've just added store Y result high. LDA pointer high and STA results high. Okay, so that's just the result. So that's going to make a lot more sense when I do this next bit. Just noticed the verification error last time, so I don't know if it yeah, the program's failed again. It's alright, as long as it's doing the main point. Alright, and bring back putty. Resets 60 dot 60 semicolon. Okay, this is just a small test for what we're doing. Cool. It just takes its time to do the memory test, that's all it is. Because it's reading and writing a whole bunch of data. Now we do 60.6 F and at location I was just thinking of a quick and dirty way to get the hexadecimal to decimal to binary. Hexadecimal to decimal. But that's up here. And that uses the it's get hex, and it's not print hex. That's not going to work either, because that yeah, no, that's not going to work. Let's not worry about that. Let's worry about that later. We can do that next time. So printing hex characters, and okay, we've gone past the memory check. No, it's further back. Okay, so let's sidetracked again, which means it's time to end the stream almost. So 6790. So that is where it is getting to. So one memory location past the current one, and if we doing the 256 blocks, it would get from the third page to the 8th page, and the 8th page is let's see, 90. Huh. Saying 2,303 bytes. It doesn't make sense, does it? But $256 times 3 plus 2303 equals 307. Okay, let's try something else. 60 dots. Let's try the whole 8K. And 60. So the third page. Let's try the third page. 32. See what this does. Probably breaks it. E4D3R. Cool, didn't break it. Yes, it gets to the end of the 33rd page. And that's perfectly fine. So why does BASIC not work? That is a question that we will answer next time. Okay, cool, cool. So it starts at 300. I just did a quick calculation. 8192 take away 7423 equals 300. Okay, so 4096. We break. We power cycle it. It's because it's got code sitting somewhere. And DD15R. Memory size for what did you type in before? 4096. 72. Which gives you 3327 bytes 3. Cool. The last thing, and this is from the OSI manual, is if you were to press enter here, it detected the memory. And then you do that. So 1500 bytes. So it did an incorrect detection of memory. Okay, cool. So for some weird reason we are still getting a break, and that is the memory address it's trying to read from when it gets the break. And A004 is nowhere near A004, and if you were to look up here, that's not even anywhere near a memory. It's not even close to a memory. It's well outside of it. Yep. It doesn't exist. In fact, I do not think I've got anything in that memory location. So, whatever it's doing, it's not doing it right. Could also mean that the OSI config is wrong here. I have changed that, and it was 3C something or other. Let's see what that does. Okay, I'm just going to leave that there. And just hopefully that compiled it. Computer's off, and Let's see. Yep. It feels like I've got a break in there somewhere and I can't remember where it is. I'm pretty sure I didn't put a break in there though. Okay, it's been 2 hours. Unless... Nope. See, it hasn't even got any breaks in the code here as well. Yeah, it's just gonna find all the zeros. Nuts. I don't even know where that's breaking. I don't even know where to find that in the code. Alright, I've had enough. Lunchtime.